All right, so now we're ready to talk about function notation. And it might be a bit unusual if you've never seen it before, but it's actually designed to be more helpful than burdening. So for function notation, most of the time we'll write something to the effect of y equals f of x, which really is just a fancy way of saying that y is a function of x. So y is a function of x. Now, as I mentioned in an earlier video, we don't always have to have x's and y's. We could have things like s of t. We could have things like q of r. But some of the more common ones might be the f of x that you saw originally, maybe a g of x, an h of x, something like that. Bottom line is, the notation is, again, just telling you that you're dealing with a function s, q, g, or h, and you have an independent variable t, r, x, or x, relatively speaking. So when it comes down to example 6, we're told to consider a circle with area a, radius r, and diameter d, and to write a as a function of d. So if we understand what's actually being asked of us, we're trying to write this, a of d, where we're going to have some big nasty formula here, and the only variable you can have in there would be d, okay, that d right there. So let's talk about the relationships of these parts of a circle. So the area of a circle is pi r squared. And we also know that the radius and diameter are related in such a way that the diameter is actually 2 times the radius. Now, in order to get area as a function of diameter, I don't want the r. In fact, I want d's. So if I take this relationship here and divide by 2, I can see that the radius equals the diameter over 2. And I'm going to take this value right here and replace it right there. That gives us a equals pi times d over 2 squared. And when we simplify this, notice your pi d squared over 4 is now your area function with regards to d, the diameter.